So Bia and I did something a little bit different. Maybe I mentioned to you guys that I'm trying to finish up. So I was very eagerly trying to kill two birds with one stone with Oceanhackweek. And one of the things that I've been doing with my PhD is collaborating with people to develop open source education modules for something called Project EDDI. And so I decided to go ahead and work on one of those modules this week. Bia, of course, has been doing a lot of this kind of work at UCSD, and she's teaching students to code in Python, so I was very fortunate to be Bia's personal student and learn from her this week. She has the patience of a saint. So this is essentially a module that we would give to a student and this will be taught in probably a 300 level volcanology course. And as a volcanologist, I know that surface deformation above a magma chamber is a pretty clear indicator that a system is experiencing unrest and may be trending towards an eruptive state. And at Axial Seamount, so who before this workshop was familiar with the Ocean Observatories Initiative? A lot of people. What about the cabled array? Fantastic. All right, so then you guys all know that the Axial Seamount volcano is part of the cabled array. So a lot of these instruments are actually located directly within the caldera. And one of the long data series that we have going there is bottom pressure instruments. And those are, of course, measuring deformation of the seafloor. So this is really something that's important for undergraduate level students to pick up on. And so I decided to do this module looking at it. So I have here some general background information for students. Whoop, a little jumpy. But this is the Axial Seamount system. So you can see, sorry guys, it's moving a little slow.
It's because it's going from here to Zoom to there. Right.
All right, so this is the Axial Seamount caldera. These are outlines of some of the eruptions that have been there, and of course some of the hydrothermal vent fields. And this is the actual main cable that's coming back to shore, which has a lot of those instruments cabled to it. And then here's an actual view showing the instrument locations as they are kind of dispersed all over the caldera. And a general description of the actual bottom pressure instruments and how they actually work. So these instruments are actually measuring the hydrostatic pressure overlying the sensor. And when you remove hydrographic effects like tides, any kind of signal that you're seeing in the data is reflecting deformation of the seafloor. So we can actually calculate the deformation at a given point from that. So what we have kind of done is taken a lot of that OI data, but also taking the predecessor data to develop an interactive visualization. Oh, we haven't actually run these.
No.
Oops. My apologies. This is going to take just a second. So we're actually having to go in and download the historic data from an FTP server here.
So the idea is that there is this, because this is going to be used by students that don't necessarily have this stuff on their computers, the idea was to minimize the amount of data that the students had to have beforehand. So it's taken straight from the FTP server, and also because the goal of this notebook is not to teach coding, we also try to minimize the amount of Python stuff that it's in the notebook. So there is this little module here, read BPR FTP, and so the actual functions to do that are outside as a pure Python file that the students will have access to. But it basically just goes to the FTP and lists all the files that it's in there and returns that as a list. And then we wanted to have that as a single pandas data frame, so it reads the data frames and concatenate all the files into a single pandas data frame.
All right.
That's really weird.
Yeah, it is weird.
Yeah, it finished already.
Okay, cool. So basically we've constructed this kind of interactive visualization tool. And what you're actually looking at here is the deformation of the seafloor with time. And so we've recorded 3 eruptions of the Axial Seamount with the deformation data. The first one is right here in 1998. You can see the caldera collapse followed by subsequent inflation, another eruption, inflation, eruption, inflation again. And so in 2014, Bill Chadwick and Scott Nooner kind of made history when they forecasted the 2015 eruption using just deformation data alone. And then in April of 2015, their forecast came true. So we've since started referring to Axial Seamount as a well-behaved system. It kind of follows those rules that we like. You reach some inflation threshold and then you erupt. So the idea here being that students can go in and decide what they think that inflation threshold actually is, and they can move this bar around. So we're going to program in some questions that will auto-populate, and they can actually explore that. But then the next thing that they can actually do is go in here and they can forecast the next eruption themselves. So they can humor the idea of, well, if it remains at this rate, it's going to be maybe earlier. But we're actually seeing that the inflation rate has slowed. So maybe it's something more like that. So we're going to, oh, that's not good. We'll fix that. Yeah, I don't know.
Oh, there's a
bar.
Oh, okay.
But yeah, so this is just kind of the introduction to that exercise. And then the next step here is actually constraining a very, very simple deformation model of an analytical solution with the deformation data and allowing students to then go and explore material properties of the host rock and actually kind of play with the link between radius of a magma chamber and the actual pressurization within the reservoir. So kind of just giving them an interactive tool to explore inflation processes and deformation at the Axial Seamount.
That's something you preloaded externally and then added the race, or
No, so
catching it from OI?
it's on the PML FTP server.
Yeah, so these are your autonomous instruments. Most of them, the historic data is, the OOI comes out in 2014. So the measurements preceding 2014 are actually autonomous instruments from Bill Chadwick and Scott Nooner and others. So Bill is actually pulling data from the OOI, and he's developing his own files. So we pull directly from that site.
Yes.
So what's the effect when it erupts? Like, how big is the radius of what's going on?
Well, most of the lava that's actually erupted is staying kind of in the caldera itself for some of the eruptions, but the 2015 eruption was unique. So it actually traveled up the North Rift Zone by a good bit, and we were having lava flows pretty far north. And that's not necessarily what we're calculating here, but one of the ideas I've toyed around with is instead, or using pressure for our pressure models, but then calculating that as a volume change instead, because the interesting thing that you could do then is look at the extruded volume of lava on the seafloor and have students kind of then, maybe more advanced students, maybe do it in a grad level class, explore that relationship between the amount of material that's erupted from the volcano to what remains in the chamber. So how do we establish equilibrium after an eruption? Yeah.
When you do that cool prediction thing, is it possible to obtain that information through the data set?
Oh, I haven't tried too much with that, but I think Philippa mentioned that if you're using the bokeh backend, it might be possible to extract that back, but I haven't implemented it yet. Because one of the ideas for more advanced would be to also just get this chunk and just do a least square feet and maybe compare the actual least square feet with what the student draw.
Right, so right now there's no extraction. There's a hovering component that just gets you kind of the date and the deformation. Yeah.
This is a comment, not a question.
Okay.
But I think this is really cool and something, I don't know if you do any outreach with the public, but this is the type of thing that potentially works really well in that type of environment.
Yeah.
It's just it's a really cool way for people to interact with the data and be like, oh, so that's what they were transferring and understand.
Yeah, that's.
Formative comments are for me.
Oh, okay.
Thank you.
I actually have a question, for everyone, because now it got me curious. Do people have experience with running this type of stuff in, let's say, an iPad or something like that?
You can create a panel with a live server, so it's not going to actually be running the whole notebook. You have to pre-compute things and put on a server. Then yes, you can still do the interaction. It's possible. And you can even live outside of the notebook. It's going to be a standalone HTML with a live kernel behind it.
Oh, that'd be cool.
Search for
Like a widget,
Python
essentially?
panel. It's kind of widget, yes.
Cool. Very cool. Yeah, that's the plan. Is so we'll publish this kind of stuff as open source education modules, and it's kind of targeted for undergraduates. But I mean, certainly you could use them in public high schools. And I do a lot of outreach with middle school, high school age kids. So if we had something like a widget that you could just play around with, that would be really cool. You know, as you're going to classrooms and speaking with people about that kind of stuff.
Sure.
Yeah, it's a
Sure.
Oh, I'll take that.
Okay. So if you look at the permission threshold, does that change after each time volcano erupts? Like if you look at all volcanoes and look at the expressions, and they're like 200 over time?
That's an interesting question, and I should preference it with saying we call this system a well-behaved system because most do not behave this way. This is amazing. If Axial Seamount is not your favorite seamount, it probably should be for that reason alone. But it is interesting because I think I know where you were going with this, being that it seems like the deformation is increased after each subsequent eruption. So it'll be interesting to see how the next one happens, but there's this idea that you're actually relieving some of the stress in the host rock, and so that might actually allow you to deform more in between eruptions. So that's something we're thinking about, and it's, you know, I'm not going to forecast the eruption right now, but in good time, yeah, you're right, I did. But in good time, we will know the answer to that question. Yeah. Okay. Thank you, guys.